Hello, physical science learners and teachers, and anyone interested in the subject. We are back again with the electricity, which will be focusing more on electric current. Remember, this electricity consists of two branches. We have got electrostatics, which deals with charges at rest, and then we have got now electric current, which deals with normally flow of charges. When charges start to flow, then we will have electric current. Hence we have got what we call conventional current, which flows from positive terminal to negative terminal. Now, in a nutshell, the electric current, by definition, it's a rate of flow of charge. The rate of flow of charge, then that is electric current. Now, in the lower grade, we learned also in the circuits that there is what we call resistance, which is normally the opposition of flow of charges. When charges flowing, they are not flowing easily. They are somehow resisted or restricted. Then that resistance is this one, and it's measured in ohms, which is your sine typical to an omega, those who know omega. Also, in grade 10, we learned that there are also 4 factors that affect the resistance of a metal wire. 4 factors affecting the resistance of a metal wire. Now these factors are, one of them will be your temperature, top in the list, very important. You'll remember this one in the Ohm's law, we'll talk about it. The higher the resistor, the higher the temperature, then the greater the resistance. And that once the wires becomes very hot, then the resistance is increasing. That's why you find in many machines, to prevent that one from happening, they use a fan to cool down the wires. Now also we have got another one that is very important, that is the length of the conductor. Now, length of the conductor, we normally say the longer the conductor, the greater the resistance. So you find this one in the distribution of electricity by Eskom, where now for every certain distance in their distribution, they have to have a substation to pick up the current that is lost because of resistance that is building up while those wires are becoming longer. Now, the other factor also is about the thickness of the conductor. Now we know about the pipes here, to say the thicker the pipe, the thicker the conductor, then the smaller the resistance. So smaller the resistance. So once we talk about water, because sometimes current we normally associate it with the way water flows. Where the pipe diameter is very small, then the water will always find it difficult to go through that. But once the diameter is bigger, then meaning that the water will flow with ease, same as the resistance, that's the case. Now, the last one is the type of material used. When we continue with this one, we'll know that now certain materials are said to be ohmic, another one they are not. So some materials are have got high resistance. Some materials have high resistance than others. So if I'm using the aluminium, another one is using iron. So the two won't have the same resistance, even if they've got the same length and the same thickness. That's what you should know. Now, moving from this factors, we come to what we learned in grade 9 as well. Somewhere in grade 9 we learned about series and parallel circuits. Series and parallel circuits. Circuits, they just normally they were referring to resistors here. Resistors, fine. Now in this case they are telling us to say, let's start with the series. Series resistors. Series will be the ones that normally arrange in this manner. R1, and then I will have R2. I can have R3. Therefore the three resistors are connected in series. If you don't know which ones are in series, we say normally they share one line. Share one line. That is the hint. If resistors are sharing one line, then those resistors are in series. How do you find the effective resistance in this? It will be their sum. R1 plus R2 plus R3. They will give us the effective resistance. 2 points that you need to note. When they are in series, the current flowing in each one of them is the same. Current is the same. So meaning that if you can connect the ammeter here, the ammeter here, and the ammeter here and here, all these 4 ammeters will read the same value. But in this one, we'll say when they are connected in series, then they divide the voltage. They are called voltage dividers. Why? Because the total voltage across the three will be the sum of the voltage across each one of them. V1, V2, V3, meaning that if I can connect the voltmeter here, call it V1, and another one here, V2, and another one here, V3, then if I connect the main here from here to here, then this voltmeter will be the sum of these 3. That's how we say they are dividing the voltage. That's about series connection. And then the parallel connection, very important. Now there should be a branch here. In the parallel, there's always a branch. Once there is a branch, then the current will split in that branch. When resistors are connected in parallel, let's talk about the easiest one, R1 and R2. Then the two are connected in parallel. Now, the first thing we say, their effective resistance will be R parallel would be 1 over R1 plus 1 over R2. Many learners now have got mathematically inclined. They can manipulate this one and say, also I can have R parallel to be 1 over R1 plus 1 over R2, all to exponent minus 1. Or I can also have the last option to say R parallel can be the same as product over sum. Product over sum. That's the case. So either of these 3 will give you the same answer if this is the case. That's how we calculate this effective resistance in this parallel combination. We move on, and 2 things that you need to know about parallel combination. Normally, when resistors are connected in parallel, if I've got R1 and R2, the 2 are connected in parallel. Now what you should know in this case, we say the current divides. Current divides, meaning that if I've got the ammeter here and another ammeter here, call it A1, and this is A2, and then this one is A3. Therefore, A3 will be the sum of A1 plus A2. That's what you should know. So they divide the current. When the current reaches this point, it's split into two fractions. So a certain fraction will go this way, another one will go this way. Now we'll talk about the relationship between the current and the resistance now. The second point will be the voltage is the same. Voltage is the same. Very important one, you must always know, remember this, that if I can connect a voltmeter here and connect another voltmeter here and connect another voltmeter across all this, then these voltmeters, all the three will read the same value. So if there's a V1, V2, V3, therefore V1 will be the same as V2, will be the same as V3. So that is when resistors are connected in parallel. The voltage is the same, but the current divides. I think it's very clear on that one. We can simply just calculate before we come to the major issue of the Ohm's law. Let's just take one simple exercise here just to see how these three methods can unfold. We've got 3 ohm resistor that is in parallel with a 6 ohm resistor. Now they say calculate the effective resistance between the two. Let's use all the 3 methods you'll see. The first option will say certain one learner can say I use the traditional one, R1 over Rp equals to 1 over R1 plus 1 over R2. Therefore, this will be the same as 1 over 3 plus 1 over 6, which will give me 1 over 2 if you use your calculator. Then, but now 1 over Rp, therefore I'm now supposed to calculate Rp, which will be, if 1 over Rp equals to 1 over 2, therefore Rp equals to 2 ohm. That is the first option. Sorry for that one. This is how it unfolds. The second option will be, we'll see now, okay, Rp equals 1 over R1 plus 1 over R2, all to exponent minus 1. This will just have to say 1 over 3 plus 1 over 6. Therefore, if you press your calculator, it will give you just 2 ohm. As simple. The last one will be Rp equals to R1 multiplied by R2. So you've got many options. You don't have a reason to fail this type of a question. So in this case, product will be now 3 multiplied by 6 divided by 3 plus 6. 18 divided by 9 will give you 2 ohm. So that's how you can get the 2 ohm. Either traditional way and then, or use this where learners are showing their mathematical skills. So in this case, you can see how to calculate the resistance here, effective resistance in a parallel combination. So you should know that, or especially in grade 11 and 12, know that, only you will be subjected to only 2 lines parallel, not 2 resistors. Please be careful on that. Only 2 lines parallel, meaning that you can have 3 resistors in one line and 1 resistor in the other one. But know that if there are 3 resistors in here, all these resistors will be in series. Therefore, their total will be parallel to this one. So if you've got 2 also is fine. But the rule is that now you must have only 2 lines parallel. So at a time. So that's what that will be dealing with in these questions. So otherwise, let's pause for now, and then we'll talk about Ohm's law and the power and the other concepts such as your internal resistance as well. Thanks a lot.